make sure you watch the story about the skier before you tune in here. So this is our lesson on slope and how to find it algebraically and from a graph. First, we need to talk about a rate of change. So slope is also called a rate of change. And what is a rate of change? It is a ratio that compares one variable to another. Okay? And on a graph, this is called the slope of the line. That's why we're talking about it. So we have to understand what it means. Right. Slope is written as a ratio. We already know it's a rate. And remember, a rate is a ratio. So slope is written as a ratio of the vertical change, which is the rise, the change in y, which is also called your rise, to the horizontal change, your x-axis, which is called your run. You run on a flat line. So that's also your change in x is your run. So your ratio is written as the vertical change over the horizontal change. And this remains constant for any 2 points on the line. Slope is written as a fraction in simplest form. And the variable for slope, we already know, the story took place on a mountain, so it stands for m. All right, let's look at the types of slope, which we already know. We already did this in the last video. So when you see a line that you're puffing up the mountain, that's a positive slope. When you see a line where he's going nice downhill, that's a negative slope. When you see a line that zooms straight across, it's a 0 slope. And when you see a line where he dies, that's an undefined slope. We don't even know his body because it's undefined. All right, so now let's get to how do we find the slope on a graph. So more specifically, yes, we know it's positive, but what is that ratio that we're looking for? So finding a slope on the graph, you were just doing your change in y. This delta means change. How is it changing on your y? Over your change in x. Okay? Now, don't mix this ratio up. You can't flip it. If you flip it and you do change in x over change in y, that's not the true ratio. Slope is always change in y over change in x. Okay? Always. So, I always start with my leftmost point. I just do. You can do it differently, but I always start with the leftmost point. So I'm going to start here. And then where does it intersect evenly on the graph? Well, it gives me a point there, so I will use it. So now I need to see my change in y. This is my y-axis. So how many does it take for me? How many times am I going to go up the y to reach this point? I'm going to go up 1, 2, 3, 4, 5, 6, 7. So I go up positive 7. And then how many times do I do my change in x, which is my run? And I go 1, 2, 3, 4. Positive 4. So my slope is 7 over 4. We already know it's positive. Okay? Look at number 2. I always start with my leftmost point. And my change in y is down 3. 1, 2, 3, negative 3. And then I go in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my slope, if it's change in y over change in x, my change in y was negative 1. My change in x was 9. So my slope is negative 1 over 9. If you look at number 3, he's zooming straight across right here. So my slope is 0. And on number 4, he's dead. So my slope is undefined. Okay? All right, let's look at the next page. And let's just do a couple more. So we'll do the odds on this page. So my change in y is 1, 2, 3, 4, 5. And my change in x is 3. So change in y is 5 over 3. So my slope is 5/3. Okay, let's look at number 7. My change in y is 1, 2, 3, 4. So I'm going up 4. And then my change in x is in the positive direction, 1, 2. So my slope is change in y is 4 over 2, which can be reduced to 2 over 1 or just 2. Okay? All right, number 9. I'm going down 1, 2, 3. So it's negative 3, and I'm going in the positive direction, 1, 2, 3, 4. So my change in y over change in x, my change in y is negative 3 over 4. So my slope is negative 3/4. Number 11, you have an undefined slope. He's dead. And number 13, he goes up 1. And he's running 1, 2, 3, 4. So my slope is 1/4. Number 15, I'm going up 2. And I'm running 1, 2, 3, 4, 5, 6. So my slope is 2, 6, which then reduces to 1/3. Okay? All right. If you have questions graphically, make sure a good opportunity is to do the odd ones or the even ones, and then I will come check those for you. All right. Now, that's how we find it from a graph, but how do we find it algebraically? Let's say we have a table or we have two ordered pairs. Then there's a formula that we're going to use. And my formula is this. Now, we know that slope is change in y over change in x. That's the ratio that we know. So the formula is change means difference. So what I can do is I can take the difference of my y values over the difference of my x values. And that's my formula. So it's still change in y over change in x, but now I just added the subtraction. So let's look at number 1. Okay. Here, what's most important is to identify your ordered pairs. This is my first ordered pair. Remember, this is x and this is y. I'm going to put a 1. This 1 represents my first ordered pair. And this still is an x, this still is a y, and I'm going to label this 2 because that's my second ordered pair. So I have 1, 2 ordered pairs. But remember, this still means x and y and x and y. Now I can just fill in numbers. I know my formula is y2 minus y1 over x2 minus x1. And the most important rule in algebra, put parentheses around whatever it is you evaluate. So y2 is 3 minus 1 over 4 minus 1. And when I simplify, I get 2/3. So my slope is 2/3. Okay? Now, sometimes you can locate slope from a graph. So let's imagine. I am taking these ordered pairs and I'm putting them in the graph. -2, 4, just like we did when we did relations. We put that on there. -2, 4, and 10, -2. Okay? So sometimes if it's in graph form, it's easy because you can look and see, okay, what's my change? How am I going from 4 to -2? Imagine a number line, right? You got 4 over here and -2 over there. How do you go from 4 to a -2? You're going to subtract 6. You subtract 4 and you subtract 2, which is 6. Then, how do you go from -2 to 10? Well, you're going to go up 12, positive 12. So, my change in y, remember, don't get this ratio confused, my change in y is -6 over 12, which reduces to -1/2. So my slope here is -1/2. Okay? So that's how you can do the formula, but a table, it's kind of easier because you can look at your change in y and you can look at your change in x. Let's do some more. Let's look at number 3. First, I'm going to label my points. This is my first ordered pair. This is my second ordered pair. And now I just fill in numbers. So my slope is -5 minus 5 over -8 minus a -4. Be careful when you have minus and -4. You have a negative and a negative, which makes a positive here. So now I get -10 over -4, which reduces to positive 5 over 2. 2 negatives make a positive, and then 5 over 2. So my slope is 5 over 2. And you'll notice when I'm writing my slope, I'm putting m equals, because that tells me what's 5 over 2? My slope is 5 over 2. All right? Let's look at number 5, and let's do this one as a table. So here's my ordered pair in table form. 5, x is 5, y is 9. And when x is 3, y is 9. What is my change from 9 to 9? It's 0. What's my change from 5 to 3? It's -2. Okay? So here, my slope is 0 over -2. What is 0 over -2? It is 0. Make sure you reduce it. So 0 over -2. I'm going to give you a little hint. This better be in your notes. Okay. I'm giving you a hint over here. It is okay to have a 0 as a numerator. It's okay because he's still alive. That means it's 0. 0 over a number is always 0. That's what it simplifies. It's okay. It is a knockout if 0's on bottom. It means he's dead. He's done. So it's a knockout when 0's on bottom because you cannot divide by 0, so that's undefined. It's okay when 0's on top. So that's a quick way to remember 0 versus undefined. All right, let's look at number 7. I'm going to label my points. That's my first ordered pair. This is my second ordered pair. So I get my slope is 3 minus 9 over 2 minus a negative 1. Well, 2 negatives make a positive, so this reduces to negative 6 over 3, which reduces to negative 2. Okay, let's look at number 9. I'm going to make it a table. So I'm going to change that into table format. 6 to 5 is negative 1. 5 to 6 is positive 1. So my change in y is negative 1 over 1, which then simplifies to negative 1. Okay, so that's how to do it algebraically. Now, let's take a look and see what happens when you're looking for a missing piece, like this. We are still going to use our formula. We're going to have to use our formula here. So I know that m equals y2 minus y1 over x2 minus x1. And now I just plug in values. So watch what happens. Now, I do want my slope to be a fraction. So I'm going to turn 2 into a fraction. And I get 2 over 1 equals 6 minus a negative 2 becomes positive over x minus a negative 3, which becomes positive. Okay, so we've done that. Now, watch what happens here. I can simplify 6 plus 2 to be 8, but this remains x plus 3. Does this look familiar? It should. This is a proportion. So remember, what do we do when we see a proportion? We put parentheses around my binomial. So immediately, I'm going to put parentheses around it. And now I'm going to multiply my extremes, 2 times x plus 3. And I'm going to set it equal to my means, which is 1 times 8. And it's 8. And you've done this. So I get 2x plus 6 equals 8. Subtract 6. And then x equals 1. So that's how we work it backwards. We set it up just like a ratio. Let's look at number 15. So m equals y2 minus y1 over x2 minus x1. I get negative 9 over 2. I'm going to keep that negative on top of my numerator so I don't get lost. So negative 9 over 2 equals y minus a negative 4 over negative 5 minus a negative 3. Positive and positive. And now my ratio is negative 9 over 2 equals y plus 4 over negative 5 plus 3 is a negative 2. So what do? Parentheses. Then I multiply my extremes to get 18 equals 2 times y plus 4. And then I distribute 2y plus 8, subtract 8, and then divide by 2. And y equals 5. All right, the bell rang. They're going nuts. So if you have questions, come and see me.